In this video, we are going to work on problems that have powers raised to powers, right? So you got something raised to another power, and how do we do that? So here's kind of the look that you got going on. You got some power, and it's being raised to another power. What do we do with that? So an example for that is if you have something like x squared and it's being cubed, what does that mean? How do we figure this out? Because there is a nice shortcut to it. So what this means is that this outside power represents how many x squares you have. So x squared times x squared times x squared is altogether 6 x's. Shortcut is you can get there by multiplying. So your property is a times b, and that is what we're looking to do. So what I find people have a hard time with is, when do we multiply and when do we add? So I do these two examples. I'm like, write these off to the side, just memorize these two, and then just refer to it. Because it's the difference between here when you add and here when you multiply. So recognizing which situation you got is huge. So I encourage people to write this off to the side until you get comfortable with it. So here it is 2 times 3, so it's going to be 3 to the 6th power. Here you're looking at x to the 12th power, because you're just multiplying those two together. Here it's going to be a to the 4th power, because it's 2 times 2. Here you're going to have n to the 15th power, 3 times 5. And then here, just because you have more pieces in here, doesn't change what you got going on. You're still taking this 3 times the 5 and 4 times the 5. It's kind of a distribution idea. It's not perfectly like distribution, but basically that's kind of the feel that you got going on. So it's x to the 15th times y to the 20th. All right, and then this last one. So we will have to deal with the negative exponent. We'll do that at the end. But the thing that people get wrong is they bring this power into everything. It's great. A lot of people get the x's right, they get the y's right. They don't get this 2 right. Is because this 3 distributes or multiplies to all the exponents. Well, even the 2, there is an exponent on it, and it's an exponent of 1. So that 3 is you are cubing the 2 just as much as you are everything else. So that's going to look like 2 to the 3rd power. So then from there, we'll kind of clean it all up. We have 2 to the 3rd, which is 8. We have x to the 15th. But this forces me to make a fraction out of it and pull the y's down, because that's all that negative exponents do, is they just move. And that is it. That is coming across a couple problems that have powers to powers.